Okay. Like I said yesterday, this next 2 units are all tied to graphing. The type of, and I think we've talked about this before. The type of graphing that we do in Math 10 is linear lines, straight lines. That's what we focus mostly on. Things like that. Okay. So we've talked about yesterday we talked about how to measure the distance of a line. I don't know if anybody remembers the formula, but you don't need to. But it was this. That is the distance formula. Difference between the x values squared plus the difference between the y values squared, square root the whole thing because it's tied into the Pythagorean theorem. We also talked about capital M. What was capital M? Midpoint. Yes, the division one. It's the middle of the line segment. It was written as a coordinate pair. There was an x value where you add the two x values together, divide by 2. Do the same for the y's and divide by 2. And I said midpoint is capital M. Okay, and there was a reason I said that. Make sure it's capital because lowercase m means something else. Well, today you find out that lowercase m is slope. Okay, capital M is midpoint, lowercase m represents the slope. So what is the slope of a line segment? Has anybody ever heard that word before in terms of math around lines? It's a measure of the steepness of the line. That's all it is. How steep is the line? The formula for it is the rise over the run. The rise is basically up. The run is side to side. I'll just say sideways. All right. The run or the rise is how fast you're going up, and the run is how fast you're going side to side. All right. Let's just practice this. We'll talk about this as we do it. So we'll come back to that. All right. Here's our line segments. AB, table AB. What is the rise? So what you do when you're measuring slope is just like we did yesterday when we were measuring the distance of a line. We broke it into a triangle and had an x and a y. You do the same thing for slope. So AB, you draw a triangle. Now it doesn't matter which way I draw the triangle. If I drew it this way, I'll show you it doesn't matter what you do, okay? You pick a point to start at. Again, it doesn't matter if you start at A or you start at B, but you pick one of those points to start at. I'll start at A. So here we go, right here at A. And you follow the line, okay? And you count. Here I am at A. 1, 2, 3, 4, 5, 6, 7. All right, that's side to side, correct? So that is my run. And it is 7. And I wrote it under rise. The run is 7. Okay? Because I went side to side. And if you go to the right, if you're counting to the right, it is positive. Okay? That's this bit up here. The run is positive if you count right. Okay? So we have positive 7. Then, from the point that you finished, okay, you count up to get to B. 1, 2. That's my run or my rise. 2. And if you count up, the rise is positive. Okay? So if you go to the right and if you go up, your numbers are always positive. Okay? So the slope formula is rise over run. The rise is 2, the run is 7. Therefore, my slope, which is lowercase m, is 2 over 7. That's it. Leave it as a fraction. I know nobody likes fractions, but you want your slope written as a fraction. Because later on, when we have to manipulate this or graph it, as a fraction, you can see what the rise and the run are. You can see the numbers or individual numbers. If you write it as a decimal, it's way harder to deal with. Okay, just to show you that it doesn't matter which method you start at. There, that's what I wanted. If I started at B and I use the green triangle, I count to the left. 1, 2, 3, 4, 5, 6, 7. Now I went left. If going right is for you guys, if going right is positive, then going left is negative. So if I'm doing it with the green one, I'll do it over here. It's the only one I'm going to do. So rise, run. My run would be -7. And then from the point I left off, I count down. 1, 2. Going up, our rise was positive. So going down, our rise is negative. So I get a rise of -2. And then the slope, which is rise over run, is going to be -2 over -7. Negative over negative makes it positive. So you get the same answer. Okay? It doesn't matter which way you go. You just have to pick one and follow it. Don't switch it halfway between. You will get them wrong then. Okay? So CD. What's the first step? CD line. What's the first thing you have to do if you want to do the slope? Do a triangle. What point do you want to start at? It doesn't matter, but which one do you want to start at? C or D? D. Okay, we're starting at D. So I started D. I'm counting 1, 2, 3, 4. 4 units to the right. Is that my run or my rise? That is your run. Is it positive or negative? Positive. From the point that I left off, I count up. 1, 2, 3, 4, 5. I went up. Is that positive or negative? Positive. What's my slope? Rise over run, so 5 over 4. That's it. Do you want to try E and F? All right, you try E and F, and I'll put the answer up in a sec. You ready? -5 over 3, is that what people got? Yep, but all I care about is the answer, right? Because it doesn't matter. You had -3 on top?
Yeah, because I would go left.
Going this way?
If I go up,
Doesn't it go up?
and then the left.
But
And then it goes down.
it's always rise over run. What's your rise? 5. And your run is -3.
Yeah.
It doesn't matter where the negative is.
Oh, okay.
As long as the 5's on top and the 3's on the bottom. It doesn't matter. All right, flip the page, please. Okay. Now, I want us to calculate the slope of all the different parts of this line. So, between A and B, so they have drawn the triangle for us. What is my run from A to B? 3. What's my rise? What's my slope?
2/3.
Okay. Now let's go A to C. What's my run for A to C? A to C? 12. What's my rise? 8. Can you reduce that fraction? What goes into 8 and 12? 4. So it reduces to 2/3. Now do A to D, please. Fifteen is your run. What's your rise? What's 10/15? What goes into 10 and 15? 5. So it reduces to 2/3. What can you conclude about the slope of a line no matter what 2 points you pick? It stays the same. Doesn't matter where you pick your points. The slope is always the same on a straight line. Sorry? What does it look like? It's just how steep the line is. Like if I have a slope of, well, you'll see in a sec, but if I have a slope of 2/3, say, is that one, and then I say, so this is m is equal to 2/3, and then I say I have a slope of 5, okay? The slope of 5 is going to be a lot steeper. That's what it would be, okay? All right, so the slopes are the same no matter where you pick the segments out of the line, all right? So the slopes are all equal. You want to do BC? All right, well, let's do it. Here's B, and we want to go to C. That's what you're doing. It doesn't matter if you pick it in the middle of it. So what's your run there? 9. What's your rise? What's 6/9 reduced to? Doesn't matter where you pick your points on the line. As long as they're on the line, the slope will always be the same. Okay. Okay. Now, look at these 2 grids here. What do you call the lines in grid A, or grid 1, sorry? Those are horizontal. And what about the lines in grid 2? Vertical. Okay. Let's look at horizontal. Grid 1. We'll do AB. M of AB. When I write lowercase m with AB as a subscript, like the little lower AB, that means the slope of line AB. So, slope is rise over run. What's my rise here? 0. I haven't gone up, right? What's my run between A and B? Is it 8? I think it is. 8. Let's just go with 8. Doesn't matter. What's 0 divided by any number? 0. So, is that going to be the same for all the lines in there? Why?
There's no rise.
There is no rise for any of the lines in grid 1. The rise is 0. So it actually doesn't matter what the denominator is. Okay? So for a horizontal line, what is the slope? 0. Horizontal lines have a slope of 0. All right? Now, grid 2. We'll do GH. Here we go. So GH, it's the rise over the run. What is the rise of this line?
10.
Sure. 10. What's the run?
0.
0. Can you divide by 0?
No.
So we say it is undefined. The slope of a vertical line is undefined. So if I say a horizontal line, you know the slope is 0. If I say a vertical line, you know the slope is undefined. Okay? Does that make sense? 10 divided by 0 you cannot do. If you try to do it in your calculator, it'll say syntax error or, I don't know, a bunch of other words. You can't do it. Going once, going twice. What are we, antenna? We can do this. All right. Last little bit here. Positive and negative slopes. Well, let's just do this. Okay. Up until this point, all the lines, if you look at the ones we were looking at, they end, I'll erase this. They end at exact points. Okay? That's not realistic. All right? So on this next page here, grid 1, you can see they don't end at exact points. We'll look at line 1. It ends here and there. I don't know the coordinates of those points, right? Because I don't know, what is this? 1, 2, 3. Is that like 3.4 or is it 3.5 or is it 3.45? Like, who knows? So we don't use those points. The points that you know the exact coordinates are when the line goes right through the corner of a box, right? A corner of a box, because then I know what the x value and the y value are. So when you draw your triangle for a line, pick points that you know, that where the line goes right through the corner. So it goes through the corner there, and it goes through the corner there. Does that make sense? I don't want to pick this one because it's in the middle, sort of a third of the way up that line. Yes?
But if I want to calculate the slope of line 1, if I only put 2 points there where 2 corners are, how am I going to calculate the half?
But what we learned back here was it doesn't matter where you pick your points, as long as they're on the line, right? Then the slope is always the same. Okay? So we pick nice, easy points for us. So line 1, I'm going to pick those 2 points. You draw your triangle off of those 2 points. Yeah, I'm going to show you. You can do the other one too. Start at one of them. It doesn't matter which one you start at. So if I start here, 1, 2, 3, that's my run, correct? And I went to the right. So is it positive or negative? Positive. My rise is 1, 2. So for line 1, the slope is the rise over the run, which is 2 over 3. Does that make sense to people?
Yeah.
Now, somebody said, what if you picked these 2 points? Do you get the same thing? You should. 1, 2, 3, 1, 2. Okay? So it doesn't matter which one you pick. All right. Can you do, we'll do line 2. So let's pick 2 points. I'm going to pick that one and that one. I'm going to draw the triangle this way, just because. What's the slope of that line? So if I start here and go left, that's -2, and then I go down, that's -5. It's going to be -5 over -2, which is just 5 over 2.
Is that the same thing? Like you can put the lines. Is that like? Remember yesterday how there's like the answer's negative? You like put
No, then 2 negatives cancel. You can have a negative slope, as we're going to see in a sec. All right, what's the slope of line 3? That's your job. Go. Line 3. One-third? All right. Okay. Here is your job. I want you to do lines 4, 5, and 6 in the table beside it, please. We ready? -2/3, -5 over 2, and -1/3.
it's okay if it's like swapped.
Yeah, if you switch the negatives, that's fine. Are we okay with that? All right. What can you conclude about a line that is negatively sloped versus a line that is positively sloped? Paris. So you're saying when it goes left, when you look at it from the left to the right, it goes up when it's positive? Is that what you're saying? That would be the correct thing. If you read a graph left to right, from the left to the right side, if the line goes up, it is positive slope. If you read it from left to right and the line goes down, that's negative slope, which is summarized at the bottom. They will say a line which rises from left to right, so it looks like this, that is a positive slope. If it falls like that, that is a negative slope. I hope so. Questions? Slope is rise over run. If you go from left to right, it's positive. Or if you rise left to right, it's positive. If you fall left to right, it's negative. When you're measuring it, draw a triangle, but pick your triangle so that the line is going right through the corner of a square. Questions 1 and 2, please, and that will be it for today.